All right, so for our second lesson today, we're going to look at logarithms as inverses to exponential functions. So I've given you an exponential graph on the top page. A logarithm to the base of b of a positive number is defined by this following formula right here. These two things are equivalent to each other, so y equals b to the x power. We can rewrite that as log base b of y equals x. The reason we can do this is because logarithms are inverses of exponential functions. So logarithms and exponential functions are inverses, they're opposites of each other. If we need to cancel one out, we're going to use the other one. So just like we would add 2 if we were trying to get rid of a -2, if we're trying to get rid of a logarithm, we can use exponentials, or if we're trying to get rid of an exponential, we can use a logarithm. In other words, logarithms undo exponential functions. An exponential function y equals b to the x power, where b is raised to the power of x. We can rewrite this as log base b of y and use our calculator to solve for x. So logarithms are commonly used when we have an exponent that is a variable. So in this case, the exponent is x. If we're trying to figure out what that exponent is, we're going to use log base b of y to figure that out. And we can use our calculator. If you pull out your calculators should all have log buttons on them. We're going to learn how to use them today. All right, so first thing we're going to do is practice rewriting equations in different forms. So the three problems we have right here are written in exponential form. There's exponents involved. We're going to write them in logarithmic form. First thing I suggest you do is to label b, x, and y. Y is going to be the number that's by itself, b is going to be the base, and x is going to be the exponent. And then we want to rewrite that as log base b of y equals x. So we're going to replace b, x, and y with these three numbers that we have labeled. So in this case, we're going to have log base b, so 3 is going to hang down at the bottom of the g. So that's log base 3 of y is 729, that's regular sized, equals x, which in this case is 6. So if I rewrite this in log form, this is what I would have as my answer. On your assignment for today, you're going to have some problems just like this. You're going to have to take them and rewrite them into a different form. So in this case, log base 3 of 729 equals 6. Looking at the next one, we have 1/2 to the third power equals 1/8. The number that's by itself is y, the base of the exponent is b, and the actual exponent itself is x. So I'm going to label these again. Y is the number that's by itself, b is the base of the exponent, and x is the exponent. So now when I go to rewrite, I need log base b. Well, b is 1/2, so 1/2 is going to hang down at the bottom of the g. Notice how small I have it written. Then I need y regular size, so 1/8 regular sized equals x, in this case 3. So log base 1/2 of 1/8 equals 3. That is your final answer. All we were asked to do is rewrite them. The 3's from this right here. So the exponent's always going to be the number that's by itself. All right, next one. Here we have 10 to the 0 power equals 1. Take a minute and label them. Y is the number that's by itself. B is the bottom or your base. X is your exponent. So you should have labeled 1 as y, b, the base of the bottom of your exponent is 10, so 10 is b, your exponent is 0, so 0 gets labeled as x. Then we're going to have log base 10 of y, which is 1, equals 0. This right here, log base 10, is called the common log. So you'll see that this right here, the common log is a base of 10. That's the log that your calculator computes. So when we type things in our calculator, we're going to use a log base 10. You'll see that written as just log. It's understood to have a base of 10 if there's no number written down there. So this one technically could be written as log 1 equals 0 without that little 10 in there. We're going to talk about that a little bit more in a few minutes. Now we're going to do the exact opposite. We're going to convert now from logarithmic form to exponential form. So we're going to label things backwards. Log base b of y equals x. So the base of your logarithm is b. The number that follows is y. The number that's by itself this time is going to be x. So now we want to rewrite this in exponential form. Remember, exponential form is b to the x power equals y. So for this one, my b, is 81. B to the x power, so my exponent needs to be 1/4. And it's going to equal y, which is 1/3. Notice when I wrote that exponent of -1/4, it's really small in the top right-hand corner of the number. Question number 2 in the middle, log base 625 of 5 equals 1/4. Take a moment and label b, x, and y. So when we rewrite this one, our base is 625. Our exponent is x, so 1/4. And then y gets put by itself, so equals 5. Take a minute and do the last one on the right-hand side. In this case, your base is 12. Your x is 2, so you're going to have 12 to the second power equals y, which is 144. This one is actually more evident because 12 squared definitely does equal 144. This one tends to make more sense because there's no fractions involved. The rest of them were true, but this one is most obvious. So that's rewriting from logarithmic form to exponential form. Again, we were just asked to rewrite them. We weren't asked to solve for anything. There's actually nothing you can do to solve these. There's no x to solve for. We're not quite there yet. Next thing you need to know is the change of base formula. If you're given a logarithm, so log base b of a, in order to type that into your calculator, you need to take log of a divided by log of b. So whatever happens to be in these two positions get moved up here and up here. This is where our calculator is going to come into play. So in this case, this is a and this is b. So my calculator, I'm going to take log of 24 divided by log of 9. So this is how we're going to use our calculators to find values for us. Again, our calculators only compute, well, the calculators we have only compute on log base 10. This is how we can type things in using log base 10 to find our answers. So in your calculator, I want you to find that log button. So you're going to type log 24, close your parenthesis, and then divided by log 9, close your parenthesis. So our instructions tell us to round to the nearest thousandth. That is 3 places after the decimal. I'm getting 1.446. Again, I'm rounding to the nearest thousandth there. Want you to try to figure out what log base 2 of 15 equals. Again, round it to the nearest thousand. So you've got to type it in, again, using that change of base formula. You're going to use log of 15 divided by log of 2. The base goes to the bottom. So log 15 divided by log 2. Again, our instructions say to round to the nearest thousandth, so we're going to have 3.907. That 6 rounds up because of the 8 that follows after it. Questions on these? There's at least 2 questions on your next test where you have to do this. You've got to know how to type these in your calculators and get the correct answers. Right. Why do we care? So here is why we care. So say we deposit $1,500 into a savings account that earns 7% interest each year. No money is added or subtracted. This time we're being asked to figure out how long will it take for our money to grow to 2,200, and that's it, no change. So in this case, we're trying to solve for that x. So this does not have interest being compounded multiple times per year. So we can, just use y equals a times b to the x power. Remember, y stands for the amount of money in the account at the end, which is $2,250. A stands for the initial amount. The initial amount that was invested is $1,500. B is our growth or decay rate. In this case, our money is growing. We went from $1,500 to $2,250. So we're going to use 1 plus the percent it's growing by is 7%. And remember, X stands for the amount of time. We don't know the time. I'm just going to put a little t there to represent time. Without logarithms, we wouldn't be able to solve this very accurately. So we want to simplify this and get this term right here by itself. So I need to get rid of that 1,500. In order to get rid of the 1,500, 1,500 is currently being multiplied by my parentheses. So I'm going to divide both sides by 1,500. There is a question exactly like this on your next test, by the way. That's going to give me 1.5 when I take 2,250 and divide it by 1,500. And then the right side, the 1,500s cancel, leaving us with 1 plus 7% all to the t power. Once I get here, there's no way I can get that t out of the position that it's in, that exponent, without using logarithms. So I'm going to label, this is b, this is x, and this is y. And I'm going to move this into a logarithmic form. So I'm going to go over here. I'm going to have log base b. So I'm going to have in parentheses 1 plus 7% of y, which is, which is 1.5. And it's going to equal x, which is t. So we've just moved that to logarithmic form. Now we got t by itself, which is what we're trying to solve for, but unfortunately we cannot write type the left-hand side into our calculator the way that it's written. We've got to use the change of base formula to separate this into 2 logs with division. So in my calculator, I'm going to take log of 1.5 and I'm going to divide it by log of 1 plus 7%. Make sure you put that 1 plus 7% in your parentheses. And that's going to tell us the time that it's going to take this deposit to grow from $1,500 to $2,250. So I want you to practice typing this in your calculator. Log 1.5, close your parenthesis, divided by log of 1 plus 7%, close your parenthesis. So when I type this in my calculator, I get 5.992805314. I'm going to round it to the nearest thousandth place, so 5.993 years. So a little less than 6 years for this person's money to grow from $1,500 to $2,250. All right, next thing we need to look at is domain and range of logarithms. In this case, the domain for any logarithm is going to be x has to be greater than whatever happens to be, oops, right here. So whatever happens to be in those parentheses must be greater than 0. For the range, your range is always going to be all real numbers. I will forewarn you that Ivy Tech for your final exam wants you to write your answers in these two forms. So negative infinity to positive infinity for your range. So we have an example down here at the bottom. So we're given log base 2 of x plus 3. That's actually this graph over here on the right-hand side. Remember that plus 3, since it's inside our parentheses, actually transforms or translates our graph to the left 3. So for our domain, all we need to do is take what's inside our parentheses here and set it greater than 0. So x plus 3 must be greater than 0. Whatever you have in those parentheses must be greater than 0. You can't take the log of a negative number. Your calculator will tell you domain error. Promise. To solve this for x, I'm going to subtract 3 from both sides, which tells me x has to be greater than negative 3. If I'm looking at x values that are greater than negative 3, that means they're going to get larger and larger, head towards positive infinity. So when I write my domain, it's going to be, bless you, negative 3 comma infinity. Any number starting with negative 3, not including negative 3, that's why I use the parentheses, all the way up to positive infinity. Any number that's bigger than negative 3 will work. Your range is going to be the same for all of these. They're going to be negative infinity to positive infinity. So that would be your domain and your range. So we got to take whatever is right here and set it greater than 0. Because only positive numbers are allowed to be located there. So for this page, we're going to try to find the domain and range of all of these. The domain means whatever's inside these parentheses must be greater than 0. So I'm going to start off with 2x plus 1 must be greater than 0. Notice I don't care about those 3's that are in this problem. I don't care about the base. I don't care about the minus 3 out at the end. I only care about what's inside those parentheses and the fact that it must be greater than 0. So I'm going to solve this for x. I'm going to subtract 1 from both sides to get 2x equals less, greater than negative 1. Divide both sides by 2. X is greater than negative 1/2. So for my domain, I need any number that's larger than, greater than negative 1/2. So for my domain, the smallest number I'm allowed to have is negative 1/2. And then I'm going to keep increasing x values all the way to positive infinity. For my range, your range will be the same for every single one of these. My range is going to be negative infinity to positive infinity. Any y value is possible. Questions on this one? All right, The one in the middle, again, we only care about this region in parentheses. The -4 out at the end does nothing for us. So we want -3x plus 9 to be greater than 0. We want whatever's in those parentheses to be positive. In order to solve for x, we're going to subtract 9 from both sides. -3x is greater than -9 now. To get x by itself, we're going to have to divide by -3. This right here is very important. When we multiply or divide by a negative number, we have to flip the symbol in the middle. So this symbol is going to go from greater than to less than. And then -9 divided by -3 is +3. So this one's a little bit different because we're dividing by a negative, which means the symbol has to change. When the symbol changes, the way we write our answer is going to have to be adjusted accordingly. So now I'm being told that my x values must be less than 3. Less than means my graph must go to the left. If my graph continues to the left, it's going to go from -infinity all the way up to +3. This may or may not be like the one that's on your final. Hint, hint. You've got to remember that when you multiply or divide by a negative number, the inequality symbol has to switch. So because we divided by that -3, since that 3 was negative, we had to flip the sign. So when we wrote our domain, the x values have to be less than 3, which means 3 is the biggest number possible. So -infinity to +3 represents any number that's smaller than 3. My range doesn't change any. It's still from -infinity to +infinity. Your range will never change. For every single one of these problems, I promise, it's -infinity to +infinity. The one on your final, they might switch these two answers and try to trick you. They might list the domain as the range is the domain, and try to get you. So your range is the one that's always, it has to be on paper. So your final's on paper. Ivy Tech requires me to send them in to them. So everybody has to take it on paper so I can send it over there. I want you to take a minute and see if you can solve this one right here. Again, the only part you care about is the 3x minus 6. You care that it's greater than 0, so go ahead and set that greater than 0 and solve for x. So you should have added 6 to both sides, then divided by 3 to get x is greater than 2, which means my domain, any x value that's greater than 2 means 2 is the smallest, and greater than, I'm going to the right to positive infinity. So my domain 2 to positive infinity. My range, as usual, is negative infinity to positive infinity. Any y value is possible.